Welcome back. Today, we're diving straight into something pretty critical: the different ways AI systems can actually be exploited.
Yeah, it's a huge area. And maybe the best place to start is um, how much the attacker actually knows about the AI model they're targeting.
Okay, so what are the main categories there?
Broadly, you've got white box attacks and black box attacks.
White box. Okay, that sounds like they know a lot. What kind of access are we talking about specifically?
We're talking complete access. Like,
Hmm.
they know the model's architecture, all the internal parameters, even the gradients.
Gradients. Remind us, those are the signals the AI uses to learn.
Exactly, the mathematical nudges it uses to adjust itself. So with white box, the attacker sees everything. It's total transparency.
And what does that let them do? I mean, if you know everything.
Well, it means they can calculate really um, optimal ways to fool the AI, super precise attacks.
Like what kind of thing?
There's something called the Carlini-Wagner attack, for instance. It can create images that look almost identical to us, but the AI gets it completely wrong.
Hmm.
Minimal changes, maximum confusion for the AI.
Wow. Okay, that's unnerving. So, if white box is seeing everything, black box must be the opposite. Flying blind?
Pretty much.
Okay.
In black box attacks, the attacker has zero knowledge of the model's insides. All they can do is feed it inputs and see what outputs they get back.
That sounds way harder. How do you even find a weakness if you can't peek under the hood?
It's definitely trickier, yeah.
Hmm.
But attackers are clever. They might build what's called a surrogate model.
A surrogate, like a copy.
Sort of. They train their own simpler model to try and mimic the target AI's behavior just based on the inputs and outputs they observe.
Okay.
Then they develop attacks against their copy and hope those same attacks work on the real hidden model. It's called transferability.
Ah, I see. Or are there other ways?
Or they use query-based methods. Just bombard the AI with inputs, analyze the outputs, and try to slowly reverse engineer how it makes decisions. It's like figuring out the rules of a game just by playing it a lot.
Right, probing it. Okay, so that's attacking based on knowledge. What about the method of attack, the actual goal? You mentioned evasion attacks. This is where it gets really interesting, right?
Absolutely. Evasion attacks are about fooling a model that's already deployed and running. You modify the input right at that moment inference time to slip past its defenses.
And you had some pretty wild real-world examples, like with cars.
Yeah, really unsettling stuff. Researchers put tiny stickers on the road, almost invisible, and it tricked a Tesla's autopilot into swerving into the wrong lane.
Seriously, just stickers.
Just stickers. Or think about stop signs, slight alterations, maybe some graffiti or stickers again, and computer vision systems suddenly read them as speed limit signs.
Okay, that's terrifying. So the AI is out there, supposedly working, but it can be manipulated in real time.
Exactly. And it's not just physical stuff. MIT researchers tweaked just a few bytes in malware files. Didn't stop the malware working, but it was enough to fool AI antivirus scanners.
So the AI thinks it's safe, but it's not. Okay, that's evasion. What about attacking the AI before it's even deployed? Poisoning attacks, you called them.
Right, poisoning is different. It's about corrupting the training data itself. You sneak bad data in while the AI is learning.
So you're messing with its education, basically.
Precisely. You compromise it from the start. Think about spam filters. An attacker could feed it lots of spam emails, but label them not spam.
Ah, so the filter learns to let that kind of spam through later.
Exactly. It learns the wrong lesson. Or, much more seriously, imagine feeding mislabeled medical images into a diagnostic AI's training set.
Leading to wrong diagnoses down the line?
Potentially, yes.
Yeah.
It undermines the fundamental trust in the AI. The damage isn't immediate. It's baked in.
Okay, that's scary in a whole different way. Then you mentioned model extraction. That sounds like stealing the AI.
That's the goal. To steal or reverse engineer a company's valuable proprietary AI model.
How? You can't just download it, can you?
Not usually. But attackers can sometimes do it just by interacting with the AI through its public interface, like an API. They send carefully crafted queries, observe the responses, and over time, they can piece together how the model works internally, or even train their own copy.
Has that actually happened?
Oh yeah. There was the DeepSeek case study, for example. People figured out ways to query large language models strategically to uncover secrets about their architecture and how they were trained.
So just by talking to it, essentially you can steal its secrets, its secret sauce.
In some cases, yes. It's a major headache for companies investing millions in developing these models.
Okay, one more category. Privacy attacks. This is about getting sensitive data out, right?
Exactly. The AI might inadvertently memorize some of the private data it was trained on. Privacy attacks try to extract that memorized information.
How does that work?
One way is through membership inference attacks. The goal is to figure out if your specific data point, say your photo or medical record, was part of the model's training set.
And people have found private stuff?
Yes, unfortunately.
Yeah.
Like private medical photos were found embedded within the training data of large public data sets like LAO and 5B. The model essentially leaked them.
Wow. So the AI becomes a potential source of leaks for the very data it was supposed to analyze securely.
It can be, yeah. And there's also model inversion. That's where attackers try to reconstruct actual training data samples just from the model's outputs.
Like getting someone's face back from a facial recognition model.
That's the kind of thing, yes.
Yeah.
Pulling the original data back out is a huge privacy concern.
Man, okay. So we've covered attacks based on knowledge, white box, black box, and then attacks based on what they do, evasion, poisoning, extraction, privacy. That's quite a range of vulnerabilities.
It really is, and honestly, this is just scratching the surface. The ways these systems can be targeted are constantly evolving.
I believe it. And actually, there are even more attack types we didn't get to today. Things that go beyond these categories. We'll actually explore those in our next deep dive.